Hello everybody and welcome. In this video we're going to be talking about power supply units, specifically PSUs for this type of Amiga, the A3000. This is my AA3000 Plus that's featured in a lot of videos previously, and as usual, at least for now, it's all spread out in bits all over the desk while I was taking the accelerator here in and out for testing the what might have been demo on the onboard A30. But that's not really our concern in this video. As I say, it's about power supplies, and as you will know from previous videos, I've been using with this machine one of these ATX Flex power supplies, because when I bought the case for this, it didn't have an original power supply, so that's why I've been using this modern one instead. But it's always been an ambition of mine to try and get hold of an original power supply for this machine. Frankly, though, they're just unavailable. However, recently, what did become available is this, which is a remake enclosure for a power supply. So that's what I'm going to be looking at in this video, just to show how this works. It's been engineered to fit the original A3000 chassis, so that it fits on there exactly like the original used to, and therefore is about as close as you can get to an original A3000 power supply. Let's take a closer look at this enclosure then. So here it is in all its glory. Just before we go any further, I just want to call out who created this, because they've got a lovely little name panel on the side here. I really like this, with a reminder of the name. I don't know if this is going to show up on the video, but Szymon Gosk is the creator of this. At the time of recording this video, there is a sales thread on Amiga by Szymon under the username arymanx. I think that's how you pronounce it. But anyway, an Amiga thread where you can register interest for these power supply enclosures by Szymon. So shout out to you. Thank you very much for this, because this is going to fit in really great into my case. But let's continue our walk around the enclosure. At the front here, we've got gaps for the power supply switch itself, a front fan, more on that later, and then this is where the power cables are actually going to come out of the PSU, just like an original power supply. We've got a lovely little 3D printed grommet in here, custom made, just to protect the cables against rubbing against the metal sides. On the side here, we've got an addition. This is, don't see this on an original power supply. I think all this is a distribution panel, basically. So this is all unconnected normally, but if you plug in one of the outputs from the power supply into this, it's going to give you multiple of these little floppy connectors to add your peripherals into. I guess one thing you're just going to have to watch out for here is if you have either a really deep old-fashioned disk drive, or maybe two on top of each other, you don't want to foul on the connectors here. I mean, it's okay if they're unconnected, as they are at the moment, but just think about that. Either physically they might get in the way, or you don't want to short against those if they're powered. Of course, you can always remove this if you need to. And then at the back, we've got our mains connector as normal, and a cutout for a much bigger fan here. As with the original power supply unit, this is oversized compared to the one on the other the front, and you can see overhangs the top of the bottom of the power supply enclosure. And I think this is what is also the case for an original PSU. The reasoning I imagine from Commodore here is that this big fan, as it spins round, would draw some air from this region and expel it out the back of the case. And so you would get a little bit of airflow from the motherboard itself, or across the motherboard itself and out the back, just a tiny bit of airflow that way. For anyone who's actually got an A3000, you will know that airflow in one of those original cases is really problematic, and they weren't designed particularly with airflow in mind. So good to have this sort of oversized fan still in this case. Let's have a quick look inside. Take this top off. if I can manage that. Right, there we go. What have we got inside? Well, here's the inside of that mains connector. We've got a 3D printed base here, more on that in a moment, and then a little circuit board in the side. Let's just talk about that for a second. Two headers, one for each fan. I believe that one's 12 volts and that one's 5 volts, but really important to get those right. And a third header here, and the purpose of this, as far as I can work out, is twofold. One is to input minus 12 volts to the circuit board, which from the minus 12 volts will create a minus 5 volts power, which is what normally comes out of an A3000 power supply. More on that in a minute. The other thing this circuit does, and I think it's this chip in the top right here that's responsible for this, is production of a tick signal. In other words, either 50 Hertz or 60 Hertz, depending on whether you're PAL or NTSC, a regular sort of clock signal, the tick signal that an original PSU produces. So that's what that little circuit board does. What else do you get in the kit? Well, a little bag of goodies here. Let's have a quick look at those. There is the power supply switch itself, a 3D printed button to go on the front of that, which matches the original. A lot of original power supplies are missing this, so it's great to have a 3D printed one. And that's the header, or the plug to go into the header on our little circuit board. So that's what comes in the kit. Let's put that to one side. I mean, I think the thing you'll probably be thinking right now is that's all very well, but where's the actual power supply itself? So that's something additional. At the time I bought the enclosure, it was possible to get one of these at the same time, or you can buy these separately yourself. And this is an ATX Flex power supply, a modern one, that is going to be the donor for the actual power supply circuit board itself. This is very much like the one I'm currently using, just a bit of a smaller size. So the basic idea here is to use this donor PSU, open it up, take out the insides, transport them to our new enclosure and rewire everything. That's the concept here. But there are one or two other things that you need even beyond that. We haven't got to the fans yet. And again, there's something that you need to get additionally. I've gone for a pair of Noctuas here, the smaller one and the bigger one. As I said before, airflow critically important on an A3000, so why not go with Noctuas and just try and get the best airflow you can. So they need to go in. And the other thing you need to source is the connector to provide all the different power lines into the circuit board, including the minus 5 volts, incidentally, which this modern power supply doesn't provide for itself, which is why the little additional circuit board is doing that. This is the motherboard connector here. Surprisingly, these are still being produced, so these are much easier to get hold of than I thought they would be. So you need one of these along with the inserts, which, by the way, have to be exactly the right type of insert to go in this connector. So the basic aim here is remove the motherboard from the PSU, remove the modern connectors here, and put on the old original A3000 connectors, put it all in the new enclosure, wire up the fans, etc. Now, that all sounds relatively straightforward when you say it quickly. Of course, what we're dealing with here is, first of all, mains voltages, and secondly, power supply to the motherboard. You know, it's just super easy, and let me do my warning here. Very easy to get this wrong. You might, first of all, injure yourself or someone else if you get the mains wiring wrong, at least. And if you wire this up incorrectly, you're going to be putting power through the wrong connectors potentially into your motherboard, and at best that's probably smoke and a bust motherboard. So there is lots that could go wrong here, potentially dangerously wrong. This is not something to undertake lightly, and you know, you do so at your own risk. So I am going to sort of build up my bravery levels here and take this on. Let's see how I get on with it. So the case is off, our modern power supply here, and I didn't really talk about what power supply this is. Let me just read out the designation here. This is an FSP group power supply, FSP 250-50 GUF, to give it its full designation. I'm sure other PSUs of a similar size will fit, but it is size that's the issue here, to make sure that this will fit inside the enclosure. Anyway, the case is off here, so we can begin to see the insides. Now, just before talking about that, one thing I did do was add on one of these IEC sockets. I think that's what they're called, aren't they? The kettle sockets on the end, so that I could test out this power supply on my Amiga first, check to make sure that it works and can drive the hardware okay before I start doing anything. Part of the reason for doing that is because the current rating on here is really small, probably too small for you to read on the feed here, but on the 5-volt line is rated for 16 amps. The one I'm actually using at the moment is rated for 20 amps, so the current is slightly lower on this one, but it does seem to be okay. So I think I'm going to be okay there. So the case is open and I can begin to take this out, but I think I'm going to need to disconnect some of this hardware first. One of the things I'm going to have to tackle in all of this is just connecting up all of these cables. So this is the standard ATX power cable. Some of these are really not going to matter at all, like the orange cables, which are 3.3 volt. That's just not used on the Amiga. Other ones use very heavily, like the red cables here, the plus 5 volts. And really what I want to do is connect up as many of these 5-volt lines individually as I can, because although each one of these cables can carry quite a lot of current, actually I want as many as I can, because it basically reduces the overall resistances that you get from inevitably the socket making contact with the plug. Things like that. It's just going to give me a better quality of power the more of these red cables I connect up. The other little challenge I'm going to have to face in all of this is that some of these lines, like the blue one here, which is minus 12 volts, there's only one of these, and I need to feed that into the motherboard, but I also need to feed that into the little circuit board within the enclosure to create the minus 5 volt line. So I'm going to have to split this somehow in order to fulfill both purposes, to the motherboard and to the little converter board. But all of that is for the future. I think the first step is just to get this circuit board out of the case next. All right, well, the PSU circuit board is now out of its enclosure. Just took a bit of persuasion. It's quite a tight fit to get that out of there. And this is what it looks like. I've just been thinking a little bit more about how all this cabling is going to be working. So the ATX power supply has 5 of the red 5-volt cables on it. So I'm going to use all of them to go into the motherboard on the A3000. And then it's got plenty of the yellow 12-volt connectors. Now, 2 there, I only need one of those, so that's fine. And as I say, there's also the single minus 12 volt, so I'm going to have to split that one because I need that for the little internal converter circuit board. I also need a 5 volt to go into that circuit board to power the chips, but also for the 5 volt fan that I showed you earlier. And I was hoping that I could just simply use this cable, which has the red and black connectors, so that would be a nice convenient way of getting 5 volts to that little circuit board, because it's already wired up for me. But just on close inspection of this fan, this is a 12-volt fan, so although this is a red cable here, actually it's the wrong power supply, so or wrong voltage. So what I'm going to have to do is not only split the minus 12 volt line here, but also one of the plus 5s, or find some other place to tap into on this circuit board where I can just easily get hold of plus 5 volts and use that instead. That does mean, say, that this needs to come out, the fan, so I need to desolder that. I'm going to have to desolder the mains connector here because I showed you earlier in the main enclosure there, it's got its own cable there that's going to go in place of that. I'm not really going to use this either. This is the extra connector you get with some PC power supplies to provide a little bit more 12 volt connectors. You can tell that from the yellow here. That's not going to be needed really, so perhaps I'll get rid of that in the process, or certainly I need to tie that back in some way. So lots of work to do here. I think I better just get on with it. So where are we up to so far? Here's our circuit board. I've removed the fan from the circuit board, and I've also redone the mains power connector. I removed this from the new enclosure just to make it a little bit easier to solder, and that is now attached into the circuit board. So I think the surgery on the power supply circuit board itself is now done, which is a bit of a relief, because just underneath here, that is a mass of connections of various different solder points. Difficult to get in among all of these and work out what's what, so I don't really want to touch that any more than I absolutely have to. So that's that done. As regards the enclosure itself, you can see I've taken the time to put the fans in, because that seems a nice easy place to start. It's probably really difficult to tell from the feed here, but what I always try and do if I can, and the cable ends up in the right place, is to always leave where the arrows are in a nice visible place. The arrow showing the airflow. So what this is showing is the airflow here. There's a little down arrow, so this fan is going to be sucking air out of the power supply. The front fan here, the arrow pointing downwards also, so the air is going to come in from the case of the Amiga through the PSU enclosure and then out the back. So that's exactly what we want. Very easy to get these things the wrong way around if you're not paying attention. So I think the next bit here is really to start doing the fairly aggressive step of dealing with this, because we don't need this connector anymore. I think the first thing to do is just start cutting all of these off, and then working out which ones of these cables I'm going to need, which is many of them, but not all of them, as I was saying before. So then start connecting them up. So really there's nothing for it but to start cutting. He says, let's try that again. Let's do these one at a time. And these kinds of drastic steps in a process like this you can't avoid indefinitely, so you just got to kind of bite the bullet and get on with it. Okay, so that's the top half separated. Now let's just do the other side. Okay, that's that done. So all the power cables now separated out. I think this is the step now where I need to just pause and think for a minute, so that I make best use of all of these. As I say, I want to use as many 5-volt connections as I can, but equally as many earths as I can as well, the black ground cables. And I just need to kind of budget for all of these, because, for example, I'm going to need the green cable to attach to the switch on the power supply, so turn the power on and off, but that will also need an earth to go with it, a ground, because the way you start one of these power supplies is if you earth the green cable, that tells the power supply to turn on. So I'm going to need a ground, an earth, to go along with the green, but then of course that uses up one. I also need another one to go to the little circuit board onboard here for it to do all its magic with the tick signal and -5 volts, etc. So that's another one gone. You know, I've just got to be slightly careful that I've got enough of these. Otherwise, I might have to sacrifice the plus 12 volt connector here. That's got 2 ground connections to it. So as I say, it just needs a little bit of thought and budgeting to make sure I've got enough of these different connections, all of the right type, before I just dive in and start crimping these and connecting them to the pins for the connectors. So just a quick update here, the switch is now soldered up, so that's easy, the green and the black. And then what I've done is to select one of the 5 volt cables and the -12 volt cable here, and I hope you can see what I've done is just to strip back a little bit of the insulation part way along each of these cables. And then what I can do is solder on a sort of branching cable coming out of 5 volts and -12, and that's what can go to the little onboard circuit board. And I can cover that with some heat shrink to just protect the joint there and also make sure it doesn't short on anything. But that's how I'm intending to sort of tap into these 2 different voltage lines whilst preserving the actual outputs to go to the Amiga itself. And this is what the result looks like. So you can see here I've spliced onto the blue cable this orange one by the side, and then protected it all as I was saying. So this is my alternate -12 volts, and the similar thing on the +5 here. This is my alternate +5. I'm just going to have to be slightly careful with the colors of these wires because they're both orange now, so just some care required. But I think the next stage is to work out the header that's going to plug into this connector here on the little circuit board, get that sorted out, which is comes with the kit, and there are the little electrical connectors and the bit of plastic that they go into. So it's a question of sort of crimping the cables onto these connectors and then putting them into the relevant holes here. And to help work out what goes where, I don't know if it's you can see this on the feed here, but on the silk screen on the little PCB, it is telling me that on the left is tick, and then the next one to the right of that is ground, +5 volts, etc., etc. So I can line them up the right way round first time. So I think that's the next step, and then it's going to be possible to put all of this inside here and start getting this sorted out, even before I've necessarily worked out what to do with all of these cables. I think if I get the guts of the thing inside here, at least things will start getting a little bit more sensible to deal with. Let me show you where I've got to with all of this, and I've brought in a little lamp here so it's a little bit easier to see. So everything is now in the enclosure. I've got the switch on the front, the mains is attached on the back, the circuit board's in place. Mains is all wired up down into the input to the circuit board there, and I've also wired up the connector here into the little mini circuit board in the enclosure with my own wires here. What I haven't done yet is put the A3000 connector on the front yet. What I want to do is get this all installed as it is, and then give it a go. I think that might be the thing I want to do next. Plug in the mains, turn it on, check the fan spin, turn it off again. Just do that really quickly, just in case anything isn't wired up correctly. Just turn the power on really quick, on and off, and then if that's all okay and that sort of passes, then what I want to do is just check the voltages coming out of these cables here, make sure they are what I'm expecting them to be, and in particular that the -5 volts and the tick signal are coming out of the 2 extra wires here, so that those are working properly. I think once that's all sorted, then I can deal with the cables on the end there. And of course, one thing I've got to do is put this 3D printed button on the switch here at the front. There we are. So that now operates the power supply. So here is the mains input connector. I'm going to plug that into there and hope I don't get electrocuted while I do that. So no, this is all earth. And now to turn the power on, let's just keep an eye on this fan down here. I hope you'll be able to see whether it starts spinning or not. There we are. That has started spinning, and also some lights have come on. Hopefully those are showing. There's a red one and a blue one I can see. I can't quite see what they're related to. And I can feel air coming out on my left hand here. So that's a good start. I'm just going to turn that off. And what do those lights correspond to? I think the top one is 5 volts and the bottom one is 12 volts, which is kind of confirmed by the fact that the fans spun. So I think the next thing to do is to get a multimeter on all of these cables and just start checking voltages. Right now the multimeter's connected up to the earth cable here. What I'm going to do is just test some of these in turn. So let's first of all do the 5 volt here. I've got this little gripper that's going to make the connection on with the power, and then I can test some of these other ones like the minus 12 volts, see how that's going. But let's just start with 5 volts because that's so important to the system as a whole. 5.14, so that is pretty much perfect. Let's just put that down somewhere carefully. Don't want that really shorting on anything. Here's the minus 12 volts. Let's see what the multimeter thinks of that. Yeah, minus 11.65, so that's looking good. Now one of these ones ought to be the minus 5 volts. Let's just try that one. Yeah, minus 5, so the converter is stepping the minus 12 volts down to minus 5, so that's looking good. And then the other orange cable, which is this one, ought to be the tick signal. So this multimeter is probably, yeah, just going to show it as 2.5 volts, 2.6 volts, moving around quite a bit because obviously it's changing between 0 and 5 or a number close to that. I wonder if I just disconnect that for a minute and shove this onto the hertz setting. Let's see if it can just measure the clock frequency for me. Ooh, clock frequency. Let's get that connected properly. 49.33 hertz. So I think we can be pretty happy with that as the 50 hertz signal. So this all seems to be functioning fine. I guess the one thing I haven't checked is the 12 volt connection, but I'm sure that is okay too. I think therefore we can move on to the next stage of beginning to wire up the A3000 motherboard connector and tidying up this mass, this bird's nest of cables basically. It all needs a lot of tidying up to try, first of all, to neaten the whole thing up because it just looks a mess, but secondly, if the cables are a bit neater, it might help the airflow inside the PSU here. Well, I've done a fair bit of cable management here just to try and tidy this up a little bit. I think it's got a little way to go to get fully neat and sorted out in here, but at least I've managed to sort out the cables that need to stay inside the case, which are these ones here, and the ones that come out, which are the ones here. The other thing I've done is, because I've got quite a few of these orange cables now, the tick one I've just marked with this little twisty here, so I always know what that one is, and therefore the other one is minus 5 volts. So I think really the thing now is to take all of these loose cables and to attach them to my A3000 power connector with the proper sort of crimp connections here. Now this is again an area where I've got to be super careful to connect things upright because I've got 3 rows of 5 pins here. I'm looking at a schematic for the A3000 that's helping me work out where the different connectors are, but of course it can sometimes be difficult to get your head around the order of the pins because they're being talked about from the point of view of the motherboard, the socket, what the connections are there, whereas for the plug that goes into it, the orientation is different. So what I am going to do is borrow from the way my adapter here that I've been using up to now, the way this is wired. So this is for connecting the ATX power supply or the ATX connector straight into there, and then it adapts it for an A3000 here. But this, if all I do is kind of orient my cables against this, then I know that the top row, for instance, here needs to be plus 5 volts. So I can use this as a guide to getting my connections wired up correctly. So I think I've just got to be patient now and work through all this, and just slowly but surely, and wire it all up. Okay, so beginning to get towards having completed all the 5-volt ones. There's one I just need to make sure of here. So the top row are all plus 5 volts, but then there is also a plus 5 volts, which is this second one in on the bottom row, second one in from the right hand side on the bottom row. That's also plus 5 volts. I think that's the plus 5 volt user line. Not quite sure why that needs separately sort of identifying, but that needs to go in here. So I want to make sure that that's covered. Let's just push that in. Yeah, so that's now my 5-volt connections all made. I don't have another 5 volts to go into this socket position here, so this will have to do with the remainder. So what have I got? 1, 2, 3, 4, 5 connections to plus 5 volts. That's probably enough. I think the next step is to do all the earths, grounds, which I believe are the middle row. Let's just check that against here. So yeah, you can see, or maybe you can't see, don't know. The second row are all the black cable connections, and then if you like, all the weird and wonderful connections are on the bottom row. So that's the way it wires up. So I think I just need to keep plugging away at this, no pun intended, and connect up all these extra wires. Making progress though. Okay, I'm not sure how easy it's going to be to see on the feed here, but now all the plus 5 volts and all the earths, the grounds are done. I therefore need to finish off on this bottom row here, which is where, as I say, all the strange, miscellaneous voltages come in. But this is where I really do need to pay attention, because I need to get exactly the right ones in the right places, obviously. So a little bit more work to do while I just work through that. I think the thing with this kind of task is just take your time. If you're not sure, check it twice, 3 times, 4 times. Doesn't matter how many times you check. Getting it right first time is what's going to matter. And equally, if you need to just take a break and come back to it later, I mean, is it really going to matter? So just, be patient, take it easy, and get it right. So just having cross-referenced against my schematic, I've already got my 5-volt user here, which is, I don't know if that is easy to see or not, but that is in the second socket from the right. But in the middle is where the tick signal goes. So I think that one's next, because that's easy to identify. It goes right in the middle. And then I can work out the other ones. Yeah, so tick signal next, and then let's take it from there. And the tick signal, of course, was the one that I had carefully put this marker on. So that's already stripped there. So just a question of inserting this in the pin and then clamping it. Get my pliers and just get this right. clamp that, make sure that's nice and tight, and then that can go in the middle. Slot that into place, and then I don't think we need this tag anymore. Let's remove that while I remember it. And then it will be a question of doing the other power lines. So what is next? So opposite, well, should we do the one in the bottom corner first? This one here is, according to my notes, is -5 volts. Goes in there, and if we just compare it with this one, you can see that that's connected up to this white cable here. But I think my ATX power supply doesn't actually supply -5 volts, so the white cable isn't connected to anything ultimately. Whereas I think the color codings here are actually trying to match the ATX spec. So this is plus 12 volts and minus 12 volts there. And the white cable, at least in theory, is -5, but you know, pretty rare these days to find an ATX power supply that does -5 volts, which is why this has the converter built in to do that. So -5 volts would be this cable here. So let's try and get that running along a similar path to all the other ones, which is there, and that's going to go in there. So like I say, just a question of taking it steady with this. Strip a bit more of that off. Right, there we are. So that is all fixed up. I think what is going to need to happen now is, first of all, a big tidy up, because this is all a bit of a mess. Sort out the cabling in here, put the lid on, and then I want to do some really careful testing of the voltages that are coming out of the pins here before this goes anywhere near an Amiga. I want to be very sure, very confident, if you like, that it is actually doing what I'm expecting it to be doing before connecting it to any valuable hardware. But definitely making progress now. It's beginning to come together and actually look like a power supply rather than just a mess of parts. Well, here she is after all of that. Quite a lot of effort to get this far, but this is what she looks like completed. Much heavier now than when I first got this case and started showing it to you, and it's completely empty. You can really feel the weight of the insides now. You can see the fan, Noctua fan at the back there. We've got side, not a lot to look at there, and out the front we've got this lovely button, just like an original power supply. And I've got my connectors here. So what have we got? The plus 12 volt connector, not that useful for anything, but I've left it on the outside of the PSU case just in case I want to use that for something else in future. I've got the motherboard connector here. This is what I need to do some testing of, just to make sure all the voltages are what I expect them to be before we really plug that into anything. I've got the floppy cables here, 2 floppy connectors, and as I said before, what you can do is connect one of them into the distributor section up here, and suddenly all of these become usable as outputs as well. So you can connect your extension cables in there. So that's quite a neat idea. And then I've got also with this donor power supply, I've got the SATA power cable here. Not very useful on an Amiga because I don't think there are any peripherals really that use that. I guess someone might have wired up a SATA drive to their Amiga, but I think what I might do in time is to take that connector off there and put a Molex on the end, one of those big 4-pin Molex connectors instead. And then that becomes a little bit more usable. Otherwise, she's ready to rock and roll, subject to some testing. So I think testing is the next thing, and then we can fit her into the machine. I think the first stage of my testing is just to check some continuity here. So I'm going to start with the plus 5-volt connections, which are all on this outside row. And all I'm going to do to begin with is just check that they all connect with each other. The multimeter at the moment is on continuity mode, so it makes a beep when there's a connection. So quickly go across those. They're all plus 5 volts. Well, they're all connected to each other. Let's just make sure they are plus 5 volts. What I'm going to do here is take the red connector from the floppy port and then connect to one of my pins, and there we go. There is a connection somewhere. Try that again. There we are. Yeah. So those motherboard connectors are connected to the 5-volt connector. And while I'm doing this, I might as well check the grounds. So let's try ground there, and that's second row. Any connection there? Interesting. Nothing. Well, let's just check that they are connected to each other first, and then we'll come back to everything else. So that does connect with that. It is connected to the outside of the enclosure there, so that does imply it is earth. And then, oh, there we go. I think it's just difficult to get a good connection on these little floppy exposed elements here. I think my probe on the end here is just slightly too big to get into the gap. But anyway, the grounds are all connected up, and then plus 12 volts again is right on the end here. Let's plug that in there. I think I can just plug that straight in, which is rather handy because it frees up a hand, and then I can connect it to this 12 volts here. Can I? Anything there? No. Interesting. Oh yeah, there is. Yeah. Maybe I do need both. Well, I need more than 2 hands here, I think. There we go. So that is connected up. So the 5, and I've lost the pin out of here. So let's put that back, because they should not be coming out. Make sure that is nice and firm. It might have been when I pushed this probe in, it actually forced the pin out. What I'm going to do instead is to test it off here. I don't really care if I mess this up too much. There's the plus 12, and oh, as always, you never quite have as many hands as you'd like to have. That's 12 volts, and that's 12 volts, yes. So that's all connected up okay. It's still not proving that I've got the pins in the right places, I suppose. Great that there's continuity through the power supply, but are the right voltages coming out of the right pins? I think what I'm going to have to do for that is to plug the power supply in and then test the voltages with it running, and at the same time compare to the adapter that I showed earlier, just make sure that is spitting out the right voltages on the right pins. So that'll be my next step. All right, now it is on to testing the voltages. What I've done is to connect the ground for the multimeter to the back. Oh no, it's come loose. The back of the power supply here, because we established earlier that this is connected to ground, so that's a rather convenient point. And then what I'm going to do is test the voltages in here, obviously once the thing's switched on. Now you might be thinking, gosh, you're really rather paranoid about all of this. Why on earth are you worrying about testing and testing and testing? The fact is that stupid mistake might as well be my middle name sometimes, and it's just really easy on something like this, particularly when you've been spending quite a long time on it, as I have today, that you get a bit weary and it's easy for mistakes to creep in, or you think you've done the right thing and it turns out you haven't. very, very easy to do. So I just think more time spent checking is time well spent. Doesn't rule out the possibility that there's still some stupid mistake somewhere, but at least you could try and minimize the chances of that. So let's power this on. And there's a nice blue color escaping from the enclosure. They are probably not coming out on the feed. But now let's see if you can see this. So there, that should be plus 5 volts, which it is. Let's just keep going along. These should all be the same, obviously, because we checked continuity before. Right. And now in the corner here, I think this is supposed to be minus 5 volts. So let's have a look. Yeah, that's minus 5 volts. And then what do we have? Oh, there's another plus 5 volts. Then we've got the tick signal. Well, we could test that. So that's still floating around 2.5, 2.6 volts. I'll check the timing on that again if I need to. And then we've got minus 12 and then plus 12 in the corner. So those are all what they should, or what I think they should be. Minus 5 in one corner and plus 12 in the other corner. I'm going to have another last look at the schematics just to check all of this before I kind of summon up the courage to plug this into the machine and just see what happens. Well, here is the power supply plugged into the motherboard there. We've got an extra cable here that I'm not using. I'm just sort of resting that over the side just to keep it out of the way. What I have plugged in is the floppy drive on the one of the extra cables here, just so that boot up doesn't take too long. I'm resting this all on a pad, by the way, just so there are no shorts. Let's just make sure the SCSI card's not going to short. Plugged into mains. Let's turn the mains on. So that's that. And what I'm going to do here is just turn it on, maybe leave it a second or two and turn it off. So that is the only thing that I'm going to do. What we should see is obviously the power light come on, drive activity light, and the fan spin up on the CPU, but I'm not really going to let it boot because I just want to see if there's life in this thing at all and no smoke, bangs, whatever. On and off really quick, see if that was all okay. If it was okay, then we could think about starting it up for just a little bit longer and see if the thing will boot. But should say I haven't tested this before. This is absolutely the first run of this plugged into the motherboard. So here we go. And yes, we did have action. Hopefully you saw there the drive lights came on, the power light came on. We even had the rapid road here spark up with the white light, which shows the CPU's working, and the fan came on. So that's a great start so far. Let's just do that again and leave it a bit longer this time. So it's making all the kinds of noises and activity that it should be doing. Drive light sparked up. It's now doing the set patch, which always seems to take a while, which is a moment to panic while it's doing its thought process. And yep, it's come out at the end of set patch. You can't see it on the monitor here, but it is actually booting into Workbench. So I can breathe out now. Been holding my breath there. This does seem to be working. And moreover, by the way, this is supplying power to my Voodoo graphics card, which is providing RTG. So there's enough juice for that. That's working okay. So I think this is looking really good now. Final step, putting the machine back together. So here she is in the Amiga chassis with that at least partially put together, back together, and this really does round off the machine for me. This is about as close as you can get to an original power supply without it actually being an original. Instead, what I've got inside, of course, is the modern PSU providing all the power, and this rather nice distributor here, which I'm going to have to make better use of, I think, and work out how to get the most out of that. But I'm really delighted with this. As I say, there was at the time of recording this video, there's a sales thread on Amiga for this enclosure, but inevitably these kinds of things are limited runs. So if you're watching this video sometime in the future, it may not be available at the time you're viewing. But I'm delighted with it. It really, as I say, completes the picture of this Amiga build. So I'm thrilled. Do join me again next time when I'll be doing more retro computer videos. Bye for now.